In section 17, we're looking at solving linear inequalities. The nice thing is that our process to solve linear inequalities is not very different from solving linear equations. What is different is the number of answers that we get and some other minor details. So in an inequality, we're going to have something that looks like this. X plus 8 is less than 9. This is not an equation. We're not solving for one value of x. We're solving for multiple values of x. But the nice thing is to solve this is, again, it's not different from equations too much. Just the middle of the expression is what changes. We had equations before, now we have inequalities. That inequality is what divides it into our two sides, if you will. So when I'm looking at x plus 8 less than 9, to solve this, to reverse, to get x by itself, on one side of the inequality, I'm going to subtract 8. Which then gives me x is less than 1. Same thing down here. Again, we have this inequality, x minus 6 greater than or equal to 0. And to solve that, I'm going to add 6 to both sides because this inequality breaks it apart. And I have x is greater than or equal to 6. So again, if we go just do a random one here, how about part C? X minus 4 is greater than 7, so there's our inequality. This is our divider. We're going to add 4 to both sides to isolate x. And we have x is greater than 11. In part 2 of the activity, really the same type of thing. We have 2x is less than or equal to 10. And to solve that, to isolate x, we would divide by 2 on both sides, because this less than or equal to symbol is what divides it up. So I have x is less than or equal to 5. And when I divide this one by 3, because again, this is my divider, I've got x is greater than negative 2. Now, here's something really cool, though. Doesn't always work the way we want it to. So look at this one right here, negative 2x less than or equal to 12. The instincts tell you, hey, divide by negative 2. Absolutely correct. That's what we want to do. But when we do that, something unintended happens. When I divide by negative 2, I would think that my answer is x is less than or equal to negative 6. But we can always test and see what actually works. If I take a number that's less than or equal to negative 6, and I'm just going to go with my next available integer, which would be negative 7, if I take that and plug it back into my original inequality, and compare it to 12, because that's what I'm supposed to do, what I end up getting is 14 is less than or equal to 12. If that doesn't work, let me test another integer. Maybe it's just a bum integer. Take negative 10. If I take negative 2 times negative 10, that gives me 20 is less than or equal to 12. That's not true either. Looking back at my work is all correct. I divided by negative 2. There must be something else going on. Let me try a different approach, and we'll see if we can make a conclusion about this. So instead of dividing by negative 2, what if I did something a little unconventional here? And what if I added 2x to both sides? I would then have 0 is less than or equal to 12 plus 2x. And my next step to solve that would be to subtract 12 from both sides. So negative 12 is less than or equal to 2x. And then my next step would be to divide by 2. Take a look at how these are different. So obviously everything's kind of flipped around. But when I solved it this way, I have that inequality is pointing at the negative 6. Over here, the inequality is pointing at the x. I can't have that because I need to be able to solve it any way that I want to, as long as I'm not breaking any math rules, and I should get the same answer. Well, if I added the 2x over, brought the 12 over, then divided by 2, I'm getting a different inequality than what I have here. What ends up happening is this method is actually correct, this method here of just dividing by -2 can work if we make a little bit of a modification. So that modification is that when we divide or multiply by a negative number, we're going to have to switch that inequality around. So instead of this is what my final answer should be. X is greater than -6. I can test any number that's greater than or equal to -6, or well, actually greater than -6. Equals is a weird case. But when I plug 0 in, that's be a good one to try, and plug it back into the original, I get a true statement. So again, the conclusion here is when we're multiplying or dividing by a negative number when solving an inequality on both sides of the inequality, you have to flip that inequality around. We didn't do that on this problem because I wasn't dividing by a negative number. I was taking a negative number and dividing it by a positive number. I don't flip the inequality around in that particular case. So in activity 2, we're going to just work through some problems that solve inequalities. The great news is these are, again, just like when we solved equations. The difference here is that now we're going to graph our solution on the number line, and it's going to be a little bit different than equations. Equations, we just put that number on, we were done, didn't have to think much about it. Here we have to figure out what kind of dot or circle are we going to put by that number, and then where are we going to put a line. You'll see what I'm talking about in a minute. So if I'm looking at Model 1, my first step is to distribute the -2. And once again, this less than sign is dividing everything. There's the left side and the right side. So here's my left side, my right side. My goal is to get x by itself. So I'm going to combine like terms. I've got x and 2x. That's going to give me 3x. 6 and -10 will give me -4. Then I'm going to bring the 4 over, so I'm going to add 4 to both sides. And I'm going to divide by 3. So now once I've got that inequality solved, x is by itself, that's exactly what I'm looking for. I'm going to go ahead and graph that. Now to graph that, I'm going to put 14 on my number line. My first question is, what kind of circle am I going to use? Am I going to use an open circle or a filled-in circle? And the difference is, are we including 14, in this case, as part of our answer or not? If we're not including it, then we're going to put an open circle. If we are including it, we're going to put a closed circle. And the way I can distinguish it is if I don't see an equal sign underneath there, which I don't, then that means it's not part of our solution. That means that 14 is going to have an open circle. If I've put the variable on the left-hand side, and I'm always going to do this because it makes it a lot easier, this little arrow here tells me essentially where to shade. But the key is that numbers over here on the number line are less than 14. So if I put numbers on here, I'd have 13, 12, and so on, all the way down to negative infinity. Anything that's lower than 14 is a solution. So I draw an arrow saying, you know what, everything over that way works. If I look at Model 2, it's again similar type of problem. I'm going to start by distributing. And I've got 4x minus 40 greater than or equal to negative 14x plus 14. I'm going to bring my x's to the left-hand side. So I'm going to add 14x. And I've got 18x minus 40 is greater than or equal to 14. So move the 40 over. So I'm going to use those reversing operations. And I've got 18x greater than or equal to 54. And I think I've got one more step to do. I'm going to divide by 18. And I've got x is greater than or equal to 3. So I'll put a 3 on the number line. And again, equal sign, different from the previous one where we didn't have an equal sign here. Now we do. So we're going to use a closed circle. 3 is part of our solution. 3 works. And numbers that are bigger than 3 are to the right. So we have 4, 5, 6, and so on. all of those numbers would fit that inequality. I'm trying to look for one here with a negative number. Let's do number 5. So number 5, my first step would be to distribute the negative 1 to get 2x plus 3 minus 7x minus 1 less than or equal to 46. So I want to put my like terms together. 2 and negative 7 is negative 5x. 3 and negative 1 is 2. So I'm going to move over the 2 by subtracting it. And I'm going to divide by the negative 5. Again, I'm dividing by a negative number, so I have to flip that inequality around. And I'm going to leave it as a fraction here, negative 44/5. Just double checking here to make sure I have everything mathematically correct, and it looks like I do. So we're good. I'm just thrown off a little bit by that fraction answer. So I'm going to put that number on the number line, negative 44/5. It's greater than or equal to, so I'm going to close that circle and shade to the right. Now in part 2 of the video, we're going to take a look at how to solve what's called a compound inequality, where we essentially have two inequalities together at one time.